It is visible. But let me just give you a brief introduction.
Your voice not audible. Okay.
Not audible. Hello.
Yes, yes. So this is your government university or what?
This is Delhi Government University.
Delhi government.
Yes.
I think a JNU also Delhi government, right? Or this is under JNU. Or JNU is different.
JNU is different university. This is JNU is Central University.
Okay, Central University. Okay, okay.
This is State Government University.
So this is funded by MHRD.
This is funded by Delhi government.
Okay, Delhi government.
So we welcome Professor Dr. Sachin Nandan Mohanty in this session. A brief about the Sachin Nandan Mohanty. He received his postdoc from IIT Kanpur in 2019 and PhD from IIT Kharagpur in year 2015 with MHRD scholarship from Government of India. He has edited 22 books in educational research. His research areas include communication, evolution, computation. Professor S. M. Mohanty has received the best paper in his from international advocacy, China, and other international conferences on software development applications organized by IIT in year 2013. He has been awarded best. His thesis has been awarded the best thesis first prize by the Computer Society of India in the year 2015. He has guided 6 PhD scholars. He has published 60 international journals, uh, uh, research papers in the journals of international review, and has been elected as a fellow of Institute of Engineers. He's senior member of the IT Telecommunications. He also is the reviewer of the Journal of Robotics and Autonomous Systems, Journal of Elsevier, Computational and Structural Biotechnology Journal Elsevier, Artificial Intelligence Review Springer, Spatial Information Research again of Springer. And today he will be delivering a talk on optimal deep learning model for early detection of lung cancer. So we welcome you. And thank you, sir, for sparing time for our FDP. And I am hopeful that the contents of your talk, they will be very, very helpful to our participants. Thank you, sir.
So first of all, I would like to thanks to invite me, Dr. Bijendra sir. And today I will be deliver the talk in this domain. And I congratulate to the organizer and the department, entire team, computer science engineering of Netaji Subhash University Technology, and of in organizing the 5 days Hotel FDP program on bio-inspired algorithms and optimization technique for emerging research area in computer applications. So I like to request all the participants, the moment you face any difficulty, you just unmute yourself and you ask what are the questions in your mind, so that it will be interaction both the direction. So I will be happy to interact in between the 2 hours talk. So today I will be learning. So we will be learn so many things. First of all, how the this classification technique and on the basis of whether it's a cancer or not, and come to the deep learning model. As you know, your workshop is basically in a bio-inspired algorithm like PSO, SEO, or vector foraging techniques. So where we consider the deep learning models, and we'll do some optimizations. So in these optimizations, how we call this optimal deep learning technique, basically we go for the autoencoder and principal component analysis. I'll then come to the one of my published paper, and is having the 200 citations as of now from last 2 years. So that will to discuss in details. So if you have any doubt, please interact me anytime of time, no problem. Let us first discuss what is mean by. So, am I audible, sir? Am I audible?
Yes, sir. You are
Okay,
Yes, sir.
okay, okay. So I will be interact to you in between. So I will ask some questions to the audience. So I have to check whether they are alert or not. So that is my where that is my principle. Where I will go, I just present like this one. So, so we'll discuss what is exactly the autoencoder means. And this autoencoder having various type of autoencoders. We'll discuss in details the drawbacks of each autoencoder in briefly. Then I come to the principal component analysis. Basically, it is used for the reduce the dimensional features and reduction techniques. Then we'll discuss the some numerical examples by using autoencoder and principal component analysis with the help of a one published paper that also I cited, and we can use how this will be work autoencoder over the principal component analysis. Then I come to the convolution neural network CNN, the very famous algorithm we can call CNN. And this CNN basically most popular in 2009, 19 and 90 onwards. Then I'll come to the related work of my published area, where I can paper the published by using the some cancer images. From related work, we derive the problem definition in terms of the accuracy, in terms of the optimizations, in terms of less error. You can say you can find out, and on the basis of how to define this problem, how to overcome this problem, and what are the strategy you have to apply to solve these problems. We'll go for the methodology, and the methods and methodology both are different. Method means the unique solutions to solve a problem. Suppose a particular problem P having many solutions, suppose S1, S2, and S3, many solutions are there. So these are called the one-on methods. So we can call here M1, M2 method, and M2 method like that. So any particular problem may be n number of solutions. But methodology tells which method is most appropriate for a particular problem. That is called the methodology. That methodology means it is a process to identify a particular method. We can call the appropriate method, or you can call the optimal method, which is suitable for solving this particular problem. That process is called the methodology. Then we come to the results and discussions and the contribution to the papers and some references. Now, so what is the autoencoder? Autoencoder basically it is the one type of ANN. ANN you might be know artificial neural network. Autoencoder is nothing but is a type of artificial neural network who used to learn efficient data codings on an unsupervised manner. That means autoencoder basically unsupervised algorithm. We can say called the unsupervised algorithm. So what is supervised? What is unsupervised? This is supervised and this is suppose unsupervised. So unsupervised means the labeled data, the labeled data information you don't have. That means no labeled data informations are available in case of unsupervised algorithm. For supervised algorithms, the labeled data is available. There is a basic fundamentals you have to clear. The labeled data must be available in case of supervised learning algorithm. But unsupervised learning algorithm, suppose you don't have any level data, so that time the autoencoder will be the very fast and fast tools you can apply the autoencoder. But the learning representations is a set of data, usually dimensional reductions, by training the network to ignore those signal noise. And autoencoder also use for the dimensional reduction technique. The dimension reduction technique. Dimension reduction techniques also autoencoder generally use for the dimension. So what is dimension reduction techniques? For example, you given a set of, suppose this is my algorithm, or you can call the some model. Some mathematical model is there, right? Suppose here I'm given n number of features, 1, 2, up to n number of features. Now the question arises. Suppose this is the y is the output. Now the question arises: are they really apply all n number of features, or who are the apply for the n out of n number of features? Who are the really appreciate? Now, suppose I tell you some example. Suppose there is a Indian cricket team. So Indian cricket team, suppose is there, right? Suppose Indian cricket team is there. Now there is some playing is going on. Some playing is going. So these are the some inputs is given, maybe in bowling or fielding or run score. Are you think all the 11 players are all the 11 players are really important to win the game? My question is, are you real all the importance of it? Sometimes what happen, only one person's may be taking the leading the game, while rest of the 10 persons may be less. So my question is here, what are the features you consider? Are they really all the features are used for the mathematical model, or some selected features are used for the mathematical model? What are the problem you given, and what are the output you are expecting? Now the question arises: is if suppose not, so what will do? These are the features are may or may not be used. So now the question is, then how to identify what are the key features who can participate in the tournament or the selection or in the mathematical model who can give the result. So that's why suppose a features input feature having the 100 dimension is there. So how to reduce the dimension reduction? You have to remove the some feature vectors or some features from the input data, and you collect the some features, selected features. We can call it optimal features. In algorithm is called optimal features, and these optimal features are really applicable for. Now how to know? So this autoencoder will be tells how to know. We'll discuss in details. Now come to the representation means. What does mean representation? The representation allow this representation. The representation means the representation basically allow.
Hello.
Yes.
Excuse me, sir.
Yes. Yes.
Sir, sorry, sir, for interruption. Sir, actually, your screen is not visible. That's why.
Oh, Chris, screen was visible.
Yes, sir.
I have to. Oh, do you want to continue the presentation? Stop screen sharing. So let me screen share again. Full screen. So what I'm writing that also not visible to you, right? Now visible?
Yes, sir.
Hello?
Yes, sir.
Now
Yes, sir.
visible, right?
Thank you, sir.
Okay. Thanks for your because I a lot of things I have written, so I do may not be got it. Okay. Let me quickly I'll do again. Let me what
Okay,
I'm
sir.
think here. Suppose I just quickly recap for 1.2 minutes. Suppose this is my mathematical model, right? And I'm given some input like that. Suppose my input is 1 up to n number of input, right? And I got some y is the output. Now my question is arises here. Can you tell me? So out of n number of features input, n number of features, are they really all the n number of features are participated in this mathematical model, or you can any decision making model? Okay, decision making model to get the output. If not, then how to select who are the inputs? Suppose x dash belongs to n, which is participated in this mathematical model to give this output. So in this n number of features, we have to find out the optimal features. The optimal features, among the n number of features who can really appreciate to involve, to participate in the decision making process will get this output. Why? And this process we call the dimension reductionality. So this dimension reductionality will be helpful on the basis of autoencoder. Another dimension reduction you might be know. One is the principal component analysis. That also we are going to discuss. And finally, I have to compare the autoencoder with principal component analysis, and you can find out which one is the better results and more accuracy in terms of data set. Right? Now, come to the autoencoder techniques. So autoencoder basically, I already told you, basically is an unsupervised learning algorithm, is a type of artificial neural network, an unsupervised learning algorithm. And this autoencoder basically used for the in a representation of learning of data set. So what is representation means? The representation means, let me explain you the different colors of the representation means, the representation means here how you code the data, and how you encode the data. Sometimes what happens, this autoencoder by own they having the coding tech mechanism, by itself they coding the data and encode the data. So when the reconstruction image will start, the input has retained much the more information present in the input. An encoded concept has become more widely popular nowadays. Now let us see how it will work one by one. So first we'll discuss the denoising autoencoder. So denoising autoencoder means, the denoising autoencoder means here is a create a corrupted copy. Let me erase. I will explain here. Here what happened? This denoising autoencoder. This autoencoder create a corrupted copy of the input, introducing some noise. Some noise will be introduced. Suppose I will be construct the image like this. Suppose hen correct recognition. Suppose I'll put this is equal to 2. So here what happened? What exactly this image belongs to? So here what we'll do, we can put here some corrupted image, will put the input, the introduction to some noise. It helps to avoid the autoencoded copy, and this is the encoder techniques. This example I will discuss in after a few slides. And this is called the bottleneck. I'll tell you what is bottleneck, just wait. Bottleneck we can call here compressed, remember, compressed representation, and this is called the decode, and this is called my output. Now, in the series of process, what is the advantage of this one? The main objective of this denoising autoencoder, this autoencoder basically use the mapping the input data to the lower dimensional data. We can manifold which describe the natural data to cancel out the error, the noise. That means it was introduced to achieve the good representation only. Such a representation is one that obtain the robust corrupted input and usually for the recovering the corresponding clean input. Second thing, setting a single thread decoder or encoder is very easy to implement. Easy in the sense, minimize the loss functions between output node and the corrupted input. But here is some demerits. The denoising auto demerits. To train the autoencoder of DNS data, it necessary to perform the preliminary stochastic mapping in order to corrupt data as well as the input. Now come to the sparse autoencoder. The sparse autoencoder will tell us have a sparsity penalty is very close to zero, but not exactly zero. The sparsity penalty is applied to hidden layer in addition to reconstruction error to prevent overfitting. What is sparsity data? The sparsity means suppose you have a data set like this. Suppose I have a binary data. Suppose this image of the binary data. I'll put 0, 1, 1, 0, 1, 1, 0, 0, 1. To prevent the output like operator, sparsity may be obtained additional terms. So we can put activation functions. Generally, sparse autoencoder visualize where the ubiquity of the nodes represented the level of activations. So I'll tell you in details what is the sparse autoencoder. Then, when you use the deep autoencoder, in deep autoencoder, what happens? So I'm coming to the another example. So this is called the deep autoencoder. Identify the networks. Suppose this is my input layer. Let me color the change. This is my input layer, and this is my output layer, and this is called the bottleneck layer. As I already discussed you, the bottleneck layer is nothing but compressed representation layer. So this is called the compressed representation layer. So now that you can put a questions, how many hidden layer we can use? Remember, the number of hidden layer must be less than equal to n cross n plus 1. So what is n? N means nothing but the input layer, and n is nothing but the feature vectors, number of feature in that input layer, and this one is terms of BIOS. So you can put the number of hidden layer, but it must be less than equal to m cross n into plus 1. This is you have to remember. M is nothing but your input vectors, n is nothing but the feature of the input vectors, and 1 is the BIOS. So in deep autoencoders, basically can be used the typical data set, the real value data. Remember, if you want to real value data, then better you give the deep autoencoder data. Now, coming to the contractive autoencoder, now next to the contractive autoencoder. Here, the objective of contractive autoencoder is to robust learn representation, having the less sensitivity over the small variation of data. Small variation of data means if your data set are very, very close, means you can take the statistical variance of the data. You take a statistical variance. The variance is very less, means you can call 0.1 to 0.3. The less variance we can use the contractive autoencoder data. And contractive autoencoder is better choice than the denoising autoencoder to learn the feature extractions. So now come to the under control autoencoder. In under complete autoencoder, what is the objective of under control autoencoder is to capture the most important features present data and how to retrieve the most important valuable data. In under complete autoencoders have the similar dimension of the hidden layer compared to the input layer. That means the number of size of the input layer must or may not be equal to the number of hidden layers in case of under complete autoencoder. The advantage is that under complete autoencoder do not need any regulations as they maximize the probability of the data to copy the input to the output. So what is regulations? I'll come into the next, here I'll tell you what is regulations. Now, in this case, you can find out the last one is the convolution, last but one is the convolution autoencoder. In this autoencoder, traditionally, this convolution autoencoder, this autoencoder traditionally use dot take the account in fact that a single or any signal, you can see the sum of the other signal. Convolution autoencoder can be used using the convolution operator. And this convolution operator, I tell you when I discuss the convolution neural network. And due to the convolution nature, the scale will be a realistic image, will be size the high dimensional image rather than the blurry images or the some image having some error. And the last but one, you can call the variation of the autoencoders. So the stack autoencoder, one data over the another data autoencoder is called the stack autoencoder. Suppose this is my one autoencoder, and the output of one autoencoder will be input to the another autoencoder. So this is called the stack autoencoder we can use in case of some algorithms. Now, here what happened? You see, my x is the input. My x is the input, and my x hat is my output. You always remember this loss function will be defined the x minus x hat, and this is nothing but the error. And in that particular error, you have to minimize the error. See, error never be zero, ever you have to minimize. So in this scale up, the complex nonlinear representation. So here what we can do, there is two things you have to remember when you implement autoencoder techniques. First thing, highly degree of correlation. That is my assumption. The assumption must be clear. High degree of correlations. High degree of correlation. For example, I tell you height and weight. Height and weight. If height increases, weight also increases. Yes or no? Tell me, yes or no? Hello? Hello? I'm asking the participant.
Yes, sir.
Yes, when height increases, the weight increases. That means there is some relationship between height and weight. We can call
Yes, sir.
correlated data. For example, I'll tell you, suppose my income, your expenditure. Is there any relation? My income and your expenditure, is there any relation?
No, sir. There is no.
Actually, there is no relation, right? If this type of data is there, then don't use any autoencoder data, right? So autoencoder basically use the data where you can got the high degree of correlation. That means if you can find you take the matrix, all the data you make the matrix and find the correlation coefficient vector. If the correlation coefficient is more than 7, so we can call it that we can autoencoder can be used. For uncorrelated data, if you use, so what happened? The input features are maybe the independent. So what is independent? Suppose I'll tell you here, y is equal to f of x. Now here, what is independent? What is dependent? Anybody can tell? Anybody can tell what is the any participant? Those are attending today lecture. Anyway, what is the independent? What is the dependent variable? Yes.
So x is independent and y is a dependent variable.
Yes, very good. So here what happened? Y basically depends upon x. So my output is y, and the nature of the function, my input is x. Remember. So here f is function is not input. Function will be the eliminated factor. X is the input. From this input x, so the function will be evaluated, and the output will be assigned to y. So that means this x is called the independent and this y dependent on x. You are correct, right? Then, so in this case, what happened? If your data are not correlation is there, that means if uncorrelated data, so what will do? The input features are maybe dependent. If the input features are dependent, then comparison of subsequent reconstruction should be difficult. In case of deep autoencoder, as I already told you, This is my input factor. And the output will get some weight matrix W1, will get another autoencoder A2. Here A2 will receive the input, not exactly the raw input, what data is given, but A2 is receive the input, the output from AE1. This is my AE1. AE1 means autoencoder 1. So output of autoencoder 1 will be assigned to autoencoder 2. Similarly, the output of the autoencoder 2 assigned to reverse way autoencoder 1. This is called the decode phase. Remember, this is called decode phase and this is called the encode phase. And you will finally get the X hat. Remember, the dimension of, I'm telling, remember again and again, the dimension of X and X hat should be same. My dear friends, I am not telling the value, I'm telling the dimension. The dimension of X and X hat should be same. If are different, that means you are losing some information. And you should be know the dimension should not be changed. Suppose this is M cross N, this should be M cross N. Otherwise, what happen? You are losing the information, right? Now, for the regularizer, basically the regularizer only tells, as I already told you, it's a technique. The regularizer is a technique which makes slightly modification to the learning algorithm so that the model will be behaves better. So this regularizer we can call, suppose, some boosting factor. Some boosting factor, you have to twist something like your delta X factor, you can twist so that the loss functions, what are using loss functions, and it will be get the model will be get the better result as compared to the previous value. And we should remember these loss functions are sensitivity enough to input to the accurate reconstruction. If data itself is not accurate, then you cannot predict your accurate result. You remember the data should be, even data should be noisy, but data should be accurate. Right? Now, here I'm coming to the autoencoder versus PCA. As I told you, this I'm going to explain last one, autoencoder PCA. I'm given one example. You try to see this example, and any doubt you can ask me any point of time. Suppose I have one binary image. I have some binary image, suppose 0, 1 values are there. Suppose, right? Suppose this is the image. I put in a x1 axis, x1 and x. This is my binary image only, right? I start from 0, 1, 2, 3, 4, 5, 6, and 7, right? Now, here also I can put here 0, 1, 2, 3, 4, 5, 6, and 7, like that I can put, right? Now, suppose these are my value. So this value, this value, this value, this value. This is my image, right? The pixel images. So I have to locate in my x direction input images is a 2 by 2 matrix, right? Now we can put a question. So how you input images in a particular matrix format? So the input images. So let me explain you your questions. This one. Suppose you have a neural network having 10 dimensions. Okay? Let me explain quickly. Suppose this is my matrix, right? Suppose I'm given the 6 dimensions. 1, 2, 3, 4. My screen visible? Hello?
Sir,
Yeah.
whatever you are writing is not visible.
Why? Oh my God. Previously visible?
No, sir, it was visible very late. Means once you were writing, after 1 minute, we were able to see that.
That
That
is
is lagging.
yeah, that is lagging concept. Okay. Suppose the features one you can call F1, F2, F3, F4, all the column feature you can note down all the column F5 and F6, right? Some value is given, some value is given. Now the question arises, how to input this my input vector in a neural network? What will do? You take this. This is called the one information, right? This is called the information one, information two. Suppose the cancer patient. Suppose this is a cancer patient CP1, cancer patient one. Suppose the age, suppose you can the hemoglobin level, or weight, or platelet count. Okay, then skin thickness, or some data like that. Okay. In this way, or you can call your the some infection level like that. So what will do? Suppose I design the neural network in such a way that so how many input filters? 6. I will input node is equal to 6. 6. So what will do? This is my x1. X1 means input 1. This is your x2 input 2. Like that x6. What will do here? You extract this feature first. Extract these features and pass here like that. Like this only. X1, X2, X3, X4, X5, X6. Then extract the next features vector. Then you extract here another features. Are you clear? Are you clear or not? So you have to extract one by one row at a time. Then you can pass it to this neural network. So this is my neural network. And this is my output. So in this way, you have to construct a 6 into 2 into 1 model. We call it a model. And these 6 stand for the input layer. This 2 stands for the hidden layer. And this 1 stands for the output layer. So as per your applications, I'm assigning here. My output may be 2, maybe 3. But in this case, I'm to predict whether it's cancer or not. That's why output is 1. If it is 1, then it's cancer. If it is 0, it's not cancer. In this way, I design my model 6 into 2 into 1. And in case of hidden layer, that depends upon you how much edge hidden layer you can increase. But in order to remember, the hidden layer should be, I already told you, m cross n plus 1. Right? Now, coming to here, I have to design what is the value of x. X is nothing but the pixel position of each data point that we can find out how to get it the informations. For example, this is the place. This is the place. So this pixel value is equal to suppose 0, 1, 2, 3, 0, 1, 2, 3, 4. So this is equal to 3, 4. Similarly, this one 0, 1, 2, 3, 4.
Excuse me,
0,
sir.
1, 2, 3, 4. Yes. Tell me 4, 4. Yes,
Sir,
yes, tell me. Tell me.
no,
Tell
sir.
me.
Actually, I was saying it was not visible on my screen. Whatever
No,
you were
no.
writing.
Whatever others are visible or not?
No, sir.
No, sir, not visible.
The screen not visible.
Screen is visible, but there is a lot of lag, so voice and video are totally disinterlinked.
Okay. So what I'm saying, so same times the writing are not synchronized, right? That's
Yes.
Yes, sir. Yes,
okay.
sir.
Okay, so I can go slowly. Now you got the X matrix here. I mean, you see the X matrix 3, 4, 4, 3, 4, 4, 4, 5,
Yes,
5,
sir.
4. Now you get right. So these 3, 4 basically one pixel position what I represent in the matrix in the blue color. Are you clear? Are you clear or not?
Yeah, sir. Yeah.
Yeah. Similarly, the fourth, if you count from beginning from 0 to 7, how many columns are there? 0, 1, 2, 3, 4, 5, 6, 7. So total is 8, right? Yes or no?
Yes, sir.
Here you can put the in a row also 0, 1, 2, 3, 4, 5, 6, 7. So total is 8 cross 8 matrix, right? Are you
Yes,
clear?
sir.
Now you see the 8 number data points are there. 3, 4 is one data point. 4, 3 is another data point. 4, 4 is another data point. Similarly, 6, 5 is another data point. So 8 number of data points are there. That means there is a 8 number of blue colors are there. You just check. Yes or no?
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8. So what I represent here, the pixel value of each dimension of your matrix I just put here. That's all. Next step, what will do? Take the mean of this one. How to take the mean of this one? Take this mean of suppose your x1 comma y1, then take the summation of xi divided by I equal 1 to n. So what will do? Now 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 divided by how much? 8. Because total number of pixels is 8, right? Now anybody can compute what is the value of this one? 3 plus 4, 7 plus 4, 11 plus 4, 15 plus 5, 20 plus 5, 25 plus 5, 30 plus 6, 36. 36 divided by 8 is equal to 4.5. I written here mu x means mean of x, that is 4.5. Similarly, this also you can again calculate. So what is the value? Now 4 plus 3 is 7 plus 4 11 plus 5 16 plus 4 20 plus 5 25, here 31 plus 5 36. Again 36 divided by 84.5. Now you clear how you are getting 4.5? Yes or no? Yes or no?
Yes, sir.
Okay, very good. Now, should I proceed? Next.
Yes, sir.
Now, what will do? This mean you have to subtract from each data point. That means you have to subtract x1 is my data point. Suppose x minus mu x, I have to compute, right? And I have to compute x minus mu x transpose. What is transpose? Row become column, no problem. So x minus mu x you already computed 4.5, 4.5. What is my x? X is 3.4, 3 and 4. So what will do? 3 minus 4.5, right? X minus mu x. Got it? So x minus mu 3 minus 4.5 is equal to minus 4.5. I mentioned here. You see my second row I mentioned here minus 4.5. Then again what happened? 4 minus 4.5. So 4 minus 4.5 is minus 0.5. I make it as minus 0.5. So this matrix is nothing but your x minus mu x. So once you know the x minus mu x, can you compute x minus mu x transpose? Yes, I can compute. So what will do? Row become column. So minus 1.5, 0.5, you multiply by this one. So this is called the transpose and this is called the x minus mu x. Then you multiply this one. I got this value. Up to this clear or not? Tell me. Up to this clear?
Yes, sir.
Yes. Like your one pixel position, the way you computed, again I'm saying, like you computed with one pixel value with a mean, similarly you compute 8 such pixel value. So similarly for 4, 3, 4, 4, 4, 5, 5, 4, 5, 5, 5, 6 and 6, 5. So in this way, I got it x minus mu x multiplied by x minus mu x transpose, again x2 minus mu x multiplied by x2 minus mu x transpose. Similarly, x8 minus mu x minus 8 x8 minus mu x transpose. So these all the matrix like this one x1, this one is x2, all x8, I combine each other. After I combine this one, I got the covariance matrix. This one, the CX. Rest in the right hand corner, you see I mentioned there is a CX. So there we can identify after combine all the pixel value. So this value, the moment you go the CS matrix, and this is called the covariance matrix, and this is CX is called the covariance matrix. From this covariance matrix, I have to make the determinant minus lambda and plus lambda, and I have to compute the zero. The moment I compute the zero, this lambda and this lambda we can call the determinant of putting by the lambda is zero in the quadratic equation. I got the quadratic equation. In that quadratic equation, I solve the two equation lambda and lambda 2. From this lambda and lambda 2, we get the your eigenvectors. Here, the E is called the eigenvector and lambda is called the eigenvalue. Remember, lambda is called the eigenvalue and E is called the eigenvector. Now, just look at here.
Excuse me.
Yes, yes. Tell me.
1 minute, sir. Sir, how did we get the CX?
CX means you got it here. You got the mu1 x1 minus mu x x1 minus mu x transpose this matrix 2.25 0.75 0.75 0.25. Yes or no? Are you getting?
No, sir. Actually, I'm not able to see CX here.
CX is right hand side is there. CX. Extremely right hand side, top of the right hand side, CX is here. 0.75, 0.375, 0.375, 0.75. This means CX. Your question is how to get CX, right?
Yes, yes, sir.
My answer is the moment you got x minus mu x into x minus mu x transpose, you
Yes,
got
sir.
this matrix, yes or no? Tell me.
हाँ जी, sir.
Then similarly आपको मिल जाएगा x2 minus mu x transpose, yes or no?
Yes, sir.
Similarly x3 मिलेगा कि नहीं मिलेगा?
Yeah, sir. Everything.
Similarly
will get.
आपको x8 मिलेगा कि नहीं मिलेगा?
Yeah, every.
सबको ऐड कर दीजिए.
Okay, sir. The addition भी.
हाँ, सबको ऐड करके डिवाइड बाय 8 कर दीजिए.
Okay, sir. Thank you.
Got it?
Yeah.
So that I got my covariance matrix, right? Got it?
Yes, sir.
Yes. Once you got the covariance matrix, I put the lambda, and this is the quadratic equation. From this quadratic equation, I got the value of lambda, and we found out the lambda and the E value. And this is nothing but lambda is nothing but your eigenvalue, and E nothing but the eigenvectors.
Yes, sir.
Now, just simple reimpose. I got the value E1 and E2. Just put the value E1 and E2 in the old picture. See, in the extreme left hand side, the same picture I'm putting extreme right hand side. Yes or no?
Yes, sir.
I'm putting the E1 E2 value. Now you just magic in this here. What do you think? After imposing the E1 E2 value, you will surprise by superimposing the eigenvector of the same image space. Here you find that if you look very carefully, you find that the direction of U1, the direction of U1 is extremely right hand side, and direction of U2 will be extremely left hand side. That means you look at the direction. That means your spread the data. Again, I'm saying within double quote spread. Your data are widely spread towards the E1 direction. That means maximum data are spreading maximum right. That what we said the lambda 1. That means the eigenvalue indicate what is the variation of the data. Again, I'm saying variation of data in direction toward the corresponding eigenvectors. Now, the less data becomes R become E2. Here, lambda 2 tells that the variance of the data in the direction is the minimum, right? Whereas I get the value of this U1 A2, you find the actually orthogonal of the data. That means the most of the pixel value you will find this direction only. Now, similarly, come to one example. This is my input images, one principal component analysis. Here, the original images, by using one principal component analysis, the output looks like. By using 5 principal component analysis, the output looks like. By using 25 principal component analysis, the output looks like. Now you see the original images, your output images, mostly very equal or very near. But this type of problems occur when if your data set looks like here. If your data set would looks like here, it's very difficult to linearly separable by using principal component analysis. That's why the autoencoder comes to market. This autoencoder will be tells draw a particular line in case of plane. You can identify which data points belongs to which class. For the nonlinear structure, the representation of data is possible in case of autoencoder, but not possible in case of principal component analysis. Coming to another example. Just look at this example. This I've cited in 2006, very good paper, and the reduction dimension level using data neural network. What they have used? They use the data set, MN-side data set they use. Then they use training images having 60,000 training images and testing images having 10,000. So you can write 0 this one, someone writing 0 this one, someone writing 0 this one, but exactly 0 looks like this. Similarly, 1 looks like this. Similarly, 2 looks like this. Similarly, the 9 looks like this. 0 to 9. A next combination of 0 to 9 combination, we can write any number of numbers. So from this data, you can find out the feature is given, the image dimension is equal to 28 features. 28 into 28, the 780 number of features, then dimension reduction to 2. See the number of features, how they reduce to 2. And the reconstructed image, they constructed to 30. They used the Adam optimizer, and learning rate is very slow. And you also try to learning rate is very slow. If you taking learning rate is high, the chances of overfitting might be is there, as well as the chances of premature conversation in your biologically inspired algorithm, as been other previous algorithm, whatever the previous day, they maybe told you the premature conversations. The chances is there means the global optima you may not be reached. So that case in the loss function mean square error they use and it was 100 times. Now look at the output of this data. Now you see, if you use the principal component analysis, you cannot easily analysis from this figure. From the picture principal component analysis, you see this red color may be 0 and this may be 1 and this may be 2. You cannot segregate which color belongs to what character represent in principal component analysis. By using two-layer autoencoder, somehow little bit you can prominently visible, but still there is a huge error is there. But if you consider having a deep autoencoder, I'm using this is the output of deep autoencoder. Now you just compare with this output and this output. The first images and last images. You see, this is quietly different one cluster. That means one character. This also having one character. This having red color having one character. This final color having one character, and this blue also having one. So this is, I'm not in 100% correct, but as compared to the previous output, is quietly prominent visible output, and that will be acceptable in case of on a deep order techniques. Now the original image is this one. Now autocorrect output will look like this, and PCA component output looks like this. If you use PCA output also visible, but that much not prominently visible as output coming from the autoencoder. Now come to the deep autoencoder. I already told you this deep autoencoder adds the input and weight matrix I consider, and the output is nothing but here output of autoencoder 1, and this output will be autoencoder 2, right? And the output of autoencoder 2 may be the output of autoencoder 3, and like so on. Otherwise, what will do, the output of the decoding of the autoencoder 2 would be the decoding to the autoencoder 1, and finally we will get this output. So this is the objective of the deep autoencoder. Now come to convolution neural network. Now I'm gradually coming to one by one. So convolution neural network means, what exactly mean convolutions? So convolutions means, suppose I have a one function, f of x is a function, right? Then I got here, so the output of the function is this one. And gs is a function. Suppose my output looks like this. So convolution is basically a mathematical operations. Convolution is basically a mathematical operation on two functions f and g. So convolution function if you define con function with respect to f of x and with respect to gx. So here f of x we can find out into gx. Consider these are the two input and output. Your output maybe looks like this. That means if input will looks like the output maybe looks like this. So that is the convolution. Then what is the time invariant? The time invariant means, suppose I have input x1 at time t, input x2 at time t, so you will get it y. So here the time invariant means, if you supply the input x1 at time t, input x1 time t plus input x2 of time t is equal to output is y1 of t plus y2 of t. Then only we convert the linearly time invariant. Otherwise, we cannot call the linear time invariant, right? Now, similarly, ellipse linear shift invariant. Now, come to the CNN architectures. Any doubt, please ask me. Now, in last 1 hour, I'll be demonstrated some example how the CNN architecture will work and how the CNN architecture is a convolution neural network is different than the artificial neural network. Remember, you might be know the web propagation neural network or feed forward feed neural network or BPNN or FNN. BPNN and feed forward neural network. In that case, what happened? What are the data you are providing? That raw data you are just providing. That's all. The input feature you are providing like that. Yes or no? And you tells to the network to train the data In case of dividing the testing and training, you will get the output y. Right? This is called the x1, x2, xn. That time what will do, you define a value of y, which is a function of x1 to x9 or x8, whatever. Now, in feed forward neural network or VPN neural network, the data is going on optimize after some number of layers and took the decision. Or my dear friends, remember in CNN, the output of the CNN will be the optimal
अच्छा
feature
ठीक
vector.
कह दो अच्छा ये कहना चाहिए कि मतलब मैं तो पहली बार सुन रहा हूँ
Optimal feature. Can you mute yourself? Any doubt you can unmute, you can ask. Rest of time you just mute yourself. Organizer is there. Can you mute the participant? Hello. Hello. Am I audible? Hello.
Yes, sir.
Can you mute the participant? I think some noise is coming. So let me tell you again. In convolutional neural network, see the convolutional neural network output of the CNN will be the optimal feature vectors, and CNN will never give output as a decision parameter, right? The CNN will give the optimal feature value. From this optimal feature value, you can apply some neural network algorithm to give the output. But in previous case, VPN and feed forward neural network, what will do in feed forward neural network and the VPN, what are the raw data, you just supply the data and get the output. But in CNN, convolutional neural network, you provide the raw features of the data, absolutely no problem, but the output is not a decision making. Output, basically the output of CNN is the optimal feature value. That is my concept. And the image you can put the input, then go for the convolutions. After that, you can put the nonlinearity. One is the ReLU method you use for the nonlinearity. I'll tell you what is ReLU. ReLU basically a rectified linear activation function. For short is the piecewise linear function that will be output to the input directly. It is a positive, otherwise it will take the 0, and it has a default activation functions, and many type of neural network becomes a model that uses the easier training neural network to achieve the better performance. And ReLU will be making the model become non-linearity. Now, this feature, this up to CNN. See, this is up to CNN. The pooling, I want to tell you what is pooling. The next slide. This is called the CNN. From the output of the CNN, you will to provide to the neural network. Any neural network, you provide the input to the neural network is a, what you receive from the output from the CNN. Everybody clear? Now, this neural network will take the decision which belongs to which class, either cancer or not cancer, whether someone is pregnant or not pregnant, someone is purchasing or not purchasing, someone is buying or not buying, or investing or not investing, that will be tells. And this I'm using this architecture, convolution layer, respective field, and nonlinearity, and the pooling will discuss one by one. And we consider a 3D images, and this 3D images nothing but the height, width, and the depth images. And you are using the filters and kernels. Remember, filters and kernels both are equal. Both are equals. 2D called the field. 2D and 3D, we can don't need difference. That's all. And the purpose of the both are same. Right? Now, when come to the kernel, basically used for the 2D, and filter we call it a 3D. And filter is nothing but combination of many kernels. So here, I just putting the data in the future map. For example, I'm just going to fundamental clear, then I'm coming to one beautiful example. This is my image space having 32 into 32 into 38, 32 into 3, that is called the RGB value. And the 10 kernel size is each kernel size I have to define 5 into 5 into 3. So we can define like that. So how to define the file size? We can call here W. I'm telling you the formula. W minus K plus P divided by S plus 1. This is the way you have to define the filter size. And the W is nothing but the input volume. This is nothing but the input. This is the input. K is nothing but the kernel size. Right? And the P is nothing but the padding. I'll tell you what is padding. And the S is nothing but the style. Now, in 10 such kernels, now you can put a question, why 10 such kernels, why not 15? Okay, you can put 15 kernels, no problem. The output feature map, my question is here, how to get output feature map? Because each kernel size is equal to 10, so output feature map definitely 10. So this is my input, this is my here, you just look at here, inner window having the kernel size. I extract the feature of the kernel, I can store here. Similarly, I can kernel size to here, right? I can feature, you can extract here. Then, with the output will get it. Total is equal to this one, 32 into 32 into 10, and each 10 having one information, that is nothing but the kernel information. So 10 such kernel, so 10 such information. Now, as I already told you the ReLU methods, in CNN architecture, what I'll do, the first convolution method you will use, then the pooling method you have to use. What is pooling? Just wait some time. Then second convolutions, then second pooling. The output of this one, this is called the optimal feature value. And this optimal feature value will input to the fully connected neural network. And this optimal feature value will tells from these images whether this images having the dog or cat or boat or bird. Now answer is saying that the 94% probability this becomes boat. Now you see the maximum is boat are there. So how will identify this one? This will identify by the fully connected neural network, not by the your output as per the image data. The optimal feature value will get the CNN. The CNN data will be input to the artificial neural network. Then finally you get the answer whether it is the boat or cat or dog like that. Now come to polling. So in these images, suppose I put my feature value images, the pooling tells that we can find the data to the max pooling, average pooling, or some pooling, or different type of poolings are there. And we extract some of the metrics. Suppose stride is equal to 2. Stride equal to 2 means this stride equal to 2 means we can do 2 by 2 matrix. 3, 2, 8, 9. What is the maximum value? 9. I extract this maximum value and store here. Then I extract two right hand side. I have to move, I have to remove this place, I have to remove this row, then I continue this one. Right? The moment I continue this one, the 5, 6, 5, 3, which is maximum? 6. I continue 6. Similarly, 4, 4, 1, 1. So what is the maximum? 4. And 6, 8, 1, 2, 1. What is the maximum? 8. So this is my feature map. That means we call the pooling reduced to the height and the width of the feature map, and the depth remains unchanged unless until we not get an output. So this is the getting the output of the using pooling. Now, if the average pooling, what happened? So 3 plus 2 plus 8 plus 9, 3 plus 2, 5, 5 plus 18, 14. 14 plus 9, we can put 23. So 23 divided by 4. In this way, you can put it. In this way, you can put. So this is called the pulling down the sample of the feature map independently to reduce the height and the width and keeping the depth in change. In the pooling layer, the steered window size need to be specified. The window size you have to side window should be, and remember the side window always to be even, maybe 2 or 4 or 6 like that. Now I'm going to the example. This is my images. You just look at why people are not using the BPN and back propagation neural network, or the we can call the feed forward neural network. I'll tell you right now. Just look at the very beautiful animal we call the koala. This type of animals generally in South Africa, they're staying in South Africa. They are. So this is a beautiful picture in koala. The image size is equal to, you see the pixel image size 19, 20 to 18, 8 into 1080 This is the huge number of how many you just see. This is the matrix having 1920 into 1080, and the 3 means the depth having 3. Are you getting or not? So depth having 3. Are you getting what I'm saying? Yes or no? Hello?
Yes,
Are you
sir.
getting image size? Yes. Now, if you consider in particular layer, if this is the image size, so you collect the first row. You collect the first row in first neural layer. As I already told you this one. Suppose my neural network this one, right? Like that. So how many? 1920 into 3. That means this first neuron, see, this is 1920 multiplied by I tell you, multiply by here 1920 1080 into 3. This is my first layer, right? If this is first layer, if I'm using some suppose hidden layer, what happened? If I'm using some hidden layer, suppose hidden layer using this 4, that means you see this data having 6 million data point. If I hidden layer is consider the 4, another 4 million. So 24 million data point. If you supply to the web propagation neural network or any type of neural network except the convolutional neural network, what happened? You will be shocked. It takes a huge amount of time to analyze this data. That's why this convolutional neural network will tells out of this dimension, can you reduce? That means all the input data, then these input features may or may not be applicable for decision making. That means the output of the CNN, see, input is same. Input is equal to 1920 into 1080 into 3. But output will be reduced value. That means optimal feature value. That optimal feature value we can supply to the neuron. Let us discuss how you did. Suppose you decide this is eye. I extract the eye portion. I extract the mouth portion. I extract the head portion. I extract the ear portion. Right? Then I extract the total mouth portion. Right? Everybody clear or not clear? Everybody clear? Hello?
Sir. Yes, sir.
Yes. Then what will do? Is it koala Y? Yes. Is it koala nose? Yes. Is it koala ears? No, yes. If both three are yes, you can say yes, it is koala face. Similarly, the body part you have to divide, the hand part divide. You can find the koala eyes, yes, then koala nose, yes, then koala hand, yes, koala leg, yes, then only, yes, it is my koala. Now, how to define this one? I'm going to next slide the way I have planned how to execute this one. This is my overall restructuring of the images. Now come to here. Suppose I consider the eyes. I consider the eye, right? I consider the eye. Suppose total eye value, I digitize the pixel value, and pixel value is equal to minus 1, 1, 1 pixel. Then I define a filter for the nose. I define the filter for eyes. I define the filter for hand. I define the filter for head. I define the filter for legs. Right? Then I multiply this one. Minus, this slide is visible or not? This slide visible?
Yes, sir.
Yes. So now this filter value I just multiply. You just see in the first matrix I make it is the green color border. This border I define as the size of the filter. My size is 3 cross 3. I define with 3 cross 3. So minus 1 into 1, minus 1. Then 1 into 1 is 1. And 1 into 1 is 1. Similarly, minus 1 into minus 1. Similarly, 1 into minus 1, minus 1. Minus 1 into 1 into minus 1. Then minus 1 into 1 into minus 1. 1 into 1 is 1. And 1 is 1 into 1. So total divided by 9 is equal to minus 0.11. And this output I put here. I'm already circle with the red color. Is it visible to you or not? I made the circle with the red color. Is it visible?
Yeah, yes, sir. Yes, sir.
Now, similarly, now what will do? Anybody can tell me what will do next? How to get this value? Anybody can tell? Anybody can tell how to do? I'm asking anyone, a participant can respond.
Shift the filter.
Yes, very good. So what will do? This position, I just make it is this one. Abbas, very good. May I know what's your name? Good name?
Sir, Deepali.
Dipali. Very good, Dipali. So here what will do? I extract the feature. Again, same process. I compute the value this one. Right? Again, what will do? For this value, I shift the feature again. Again, I get the value. If you see picture again, so what will do? You coming to here, but another data set is not with me, so we can stop. We cannot compute this one. That's why we are computing the size of this matrix E1 minus size of this matrix 1. So in this way, I got this value. Once you got this value, I'm coming to just back. See, the convolution is going on, right? Convolution is done. Now coming to non-linearity. In non-linearity, what we'll do, minus 0.11, I'm using the ReLU method. So I already told you what is the role of ReLU method. The ReLU method will tells if it is positive or greater than 1, put 1. I'm putting here. If it is minus 1 or less than 1, it is 0. So this is minus 0.11 is less than 1. That's why 0. This is 1. I'm putting 1. This is minus 0.1 less than 0. 0. So this is 1. So in this way, you are putting this. And this is value. Again, you put the max polling. And this process go on repeat and repeat unless until you are not getting the optimal value. And this is for the loopy pattern for the ear, eye, nose, hand, head gesture and leg, everything will do it. After that, what will do? This is my hand detector. This is my filter of the hand detector. I'll put 1. And this hand detector will be circulated everywhere throughout the image. But filter will be exactly mapped where it is 1, you will extract the 1 only. And I got the eye, then I got the nose, then I got the ears, then I combine these things, I got the head. Because as you know, head is combination nothing but eye, nose, ear, right? Similarly, I can find out the convolution for ReLU methods. Eye, nose, ear, I just combine, then apply the pooling method and convolution from pooling. Again, I put pooling for the minimize the data. So here, what are the I'm getting here from left hand side? That is nothing but the feature extraction. This is not output. Remember, I'm not telling output. This is the only feature extraction. The output of the feature extraction, this is called the CNN. The output of the feature extraction will be input to the neural network. And this is the neuron of the neural network, input layer. So in this, you can put number of hidden layer, 10, 20, 30, 1, 2, whatever maybe. Output is this one. But the input to this is the back propagation neural network or any type of neural network you can put, or you can put a Boltzmann neural network, you can put feed forward neural network or back propagation neural network, any neural network you can put. But the input data of what you supply to the neural network must be the output of the CNN. After that, this is the only classifications. From this classification, yes, it is a koala. So in this way, we got the output and the help of the CNN. Now, just recap the convolution methods, then ReLU for the, we can call the non-linearity methods, and the pooling basically use the dimensional computation. And the convolution tells the connection sparsity reduce the overfitting, and the convolution pooling gives the location invariant feature detection and parameter sharing. The ReLU method introduced the non-linearity method and speed up the training and faster compute. And pooling basically reduce the dimensional computation and reduce the overfitting techniques. And basically, you do overfitting on, we can call it in the bio-inspired algorithm. Basically, you are called is a we can call that terms the premature convolutions, right? To make the model tolerant toward the smaller decimal variation. Now come to, this is the article I am going to explain. So as of now, I detail explain you what is autoencoder, what is different type of autoencoder, then convolutional neural networks, then come to the application of convolutional neural networks. I reply here. This paper was published in 2019, late 19, I don't know, December month, and I have submitted in the month of January. Within the 2 years time, so around 200 citations this paper, and this is 4.6 impact factor, and a huge number of comments. After 3 times of revision, the paper will accepted. The future generation computer system is ACA paper. So this is one of my PhD scholar. I did this one. Okay, let me tell you what exactly happened with this one. Now, here, this is the right hand side, this is the human lungs, and this is called the right, left and right lobe. During pandemic time, those in your family you might be know, the word might be hard CT score. CT score. Or you can call the HRCT score. Right? HRCT score means high resolution computed tomography score. What it means score? Our lungs, human lungs, divide into 5 lobes. This is one part, this is middle part, and this lower part. And the right hand side lungs is 2 parts. But again, each part divided by into 5. So total is equal to 25. So your score will be 25. You might be hard. Your friends or relative may be affected by COVID. Doctor maybe at the time maybe told you if the score is equal to 15 by 25. Have you heard someone? Have you heard someone or not? Hello? I'm asking the question.
Yes, sir, we have.
You heard, na? You okay. So what is meaning? 15 by 25 means, you see, this person's lungs will be affected. That means, if you calculate 25 parts, your total lungs, these 15 parts already affected. Means more than 60% already affected. Are you getting or not? This is called the HRCT ratio. And those are having 18 by 25. They might be depends upon 8-liter oxygen or NIV support. Those are having 20 by 25, there may be ventilator support. Right? That means 20 out of 25 parts, 20% is already affected. Are you getting 20 parts already affected? So that is called the HRCT score. In the lung disease are the measures. I will tell the abstract of this. The computed tomography CT images. In my study, I use the CT images. And the CT scan. So what is the cancer here? Any abnormal growth of tissue, any part of the body, not only the lungs. You go to 20 years back, you might be had the only one cancer, that is called blood cancer. Yes or no? Nowadays, every cancer is possible. Maybe skin cancer, maybe eye cancer, maybe nose cancer, many cancer, pancreas cancer, liver cancer, colon cancer, right? Many cancer. Right? So lung cancer is one of the major role in a major problem in our India. In this case, the CT scan of lungs images we have computed. In this data, we are using the male image having 30 to 48 years and female MAES sort of 22% and male 78%, total populations. And results show that the classifiers sensitivity is 96.2% and accuracy 90. Now we can put a question, so why accuracy is less? Okay, our objective is not a high accuracy. Our objective is even this model, the convolutional neural network model, is perfectly work in terms of optimal deep neural networks. Is a feature factor or not? That is more concern. Now, in further study may be possible in this. We extend this study by using some other technique, but our ODNN, optimal deep neural network, is getting better, good result, so satisfactory result as compared to the other method. I tell you. And the suitable individual diagnosis early stage and sickness are not treatables. And now, this is the output. 99% 82 are affected due to smoking habit. As you know, the lung cancers. So here, the symptoms and causes, the prolonged cough, these are symptoms, weight loss, and these are the symptoms. And mycoplasma pneumonia may be the causes of this one. Other the causes are there, the grain dust. These are the I got the from the literature review or related work. The related work, you got it. And for the diagnosis, we'll got it the high resolution CT images. You don't do that, go for the biopsy. This biopsy will tells you this high resolution the CT image tells you whether the cancer or not cancer. And biopsy will tells you the level of cancer, the stage 1 or stage 2 or stage 3. Okay. Now the delimitation of study is not required at all. Okay, coming to in experimental work, the how I did this work in terms of the experimental method. In this experimental method, in the methodology sections, we worked on the basis of filter the data first. After the filter data, the CT images, and the CT images, some images are not blurry images, so we just enhance the images by some techniques. Then after that, go for the pre-processing. The pre-processing is nothing but your filtering and contrast. And after that, the feature extractions. So feature extraction we divide in 3 ways: histogram feature extraction, textual feature extraction, and wavelet feature extraction. After that, the feature reduction by using LDA, just like a principal component analysis, you are using linear discriminant analysis. Then the classification CT images. Then finally, you apply the deep neural network and stable function. And after that, in this method, we have used the ODNL, optimal deep neural network. And what you experimental setup design, same thing we represent here. This is the database we consider around 340 images. Then after the filtering method, you can low Kalman filters you can use, and pre-processing design, then enhance images, and this is the we call the actual images. Then after that, feature expression, and the feature expression I already told you, these are the text feature, wavelet features. Then you find out the you can the histogram features. So these are the features we have extracted. And after that, in energy, entropy, homogeneity, we can call the correlation and the contrasting that feature if you extract. And in terms of wavelet feature extraction, we find the correlation coefficient features and feature reduction techniques by using the linear discriminant analysis for informational index existing to specify the characteristics of different features. And after that, we reduce the features, and after that we can do ODNL in this one dealing classification and find out the 3-level classification: normal images, benign, and malignant. So that the two cancer measure, cancer is the first stage and the cancer is the second, third stage is a normal image. And these are the test images also we can separate. Now, this is a linear regression analysis, as a principal component analysis, same phenomena. You are using. Now come to the reduced feature map. What happened? So, what is anybody can guess why I'm putting these reduced features? Why I'm putting the reduced features? Anyone here? Anyone can guess here? Where I'm getting this one? Anyone can? Where I'm getting the reduced features? Tell me. Anyone? Anyone can tell? Anyone can tell? Dipali or anyone can tell? This reduced feature is nothing but output of what? CNN. this output of the CNN will be provided to reduce feature of the neural network. Again, I'm going to that images. You just see this one. The output up to this reduced feature, you get it. My screen visible? My screen visible?
Yes, sir.
The output of the CNN, this is the reduced features. In other terms, we call the optimal feature vector. And this optimal feature vector will input to the neural network. And this is the same way I did it this year. And by using the hidden layer, this is the, you can find out by using hidden layer the fitness function use, then find the best result by selecting random value. We can find the outlet layer, here class 1, class 2, class 3. These are the my class 1, class 2, class 3, normal, benign, and the malignant. And this value will get the output. Now, coming to this here, use the confusion matrix. What is the role of confusion matrix? Let me tell you. Here space is there, I can define. Everybody might be know the confusion matrix, but still I'm telling you. In a machine learning algorithms, you have to find the confusion matrix. A confusion matrix will tells is an n cross n matrix used for the evaluating the performance of your classification model. Remember, double quote with saying the performance of a classification model. Here n is nothing number of target classes. Suppose I'll tell you, suppose here cancer, here not cancer. These are my two classes problem. Cancer, not cancer. But cancer, I got the therapy, my treatment, not therapy or no therapy. Suppose you have designed an algorithm. Suppose Apollo Hospital given assign a task. You design a machine learning algorithm, they have to implement. Suppose your problem or your algorithm given a particular person or patient actual having cancer but getting therapy, absolutely no problem, right? A patient having cancer but therapy, no problem. That is called the true positive. Remember, a person having cancer but not getting therapy, that is called the false positive. Why false positive? Actually cancer, but your algorithm tells is not a cancer, right? So as per the suggestion, we are not giving therapy. That is false positive. Here also, a person having not a cancer, but you given therapy, that is called the false negative. But a person having no cancer, no therapy, that is called the true negative. But remember one thing, absolutely there is no problem in case of true positive and the true negative. The problems occurs only in this case when the false positive case and the false negative case. And the false positive case, that means a person having cancer and not assigning the therapy are called the type 1 error. Remember, in statistics, we call the type 1 error. And the type 2 error, this is called the a person having your predicted class having a not cancer, but you are predicting is a cancer, you are getting therapy, that is called the type 2 error. So this type 1, type 2 error, you remember. So it is very, very careful. So always you try to, the false positive will be reduced and the false negative should be reduced. On the basis of this false positive, false negative, we can compute the accuracy. So accuracy means true positive or true negative divides by true positive or true negative plus false positive and false negative. Since the denominator and numerators, true positive, true negatives are same, only depends upon the false positive and false negative. If the false positive, false negative will reduce, your accuracy will be increases. So that's why the accuracy is most important factor. And our algorithm suggested that the specificity and accuracy and the sensitivity. And the ODNN method, you see the ODNN method, it gives around 96, I think 96.5 to the accuracy in compared to other method. In my data, I consider 500 records. We use the k-fold called validation. So what is k-fold validation? So let me explain you. Suppose this is the space is there, I can explain here. Suppose your data set is equal to 100 data set, right? So we can call the D1, D2 like that, D100, right? You make it is 10 slab each other. So what happened? D1 to D10, one fold, we can call the K1. D11 to D9, D20, K2. Similarly, the next K10, how much? Anybody can tell? K10 is equal to, anybody can tell? D92, D91 to D100. Everybody got it or not got it? Tell me. Hello? Everybody got it? Hello?
Yes,
Uh,
sir.
you got it? What I'm saying? Are you understood? So
Yes,
all the
sir.
data points are divided into 10 such data points. Okay. So this is called the k is equal to 10. K is equal to 10 means I call this one is the 10 cross validation. 10k cross validation. Okay. So what will do? The first training and testing. Training and testing. So what we'll do here? First K1 will be training and K2 to K10 become testing. Then find the accuracy. Again, what happened? K1 and K2 become training, K3 to K10 become testing. Then find the accuracy. Similarly, K1 to, you can dot, you can find out. K1 to K19 become training. Then K1 become testing. So in this, we can find out 1 versus 9, 2 versus 8, 3 versus 7, 4 versus 6, like that 1 versus 9. Again will come. So we can find out this one. So we'll get here in our data, I divide into 35k means 35 validation. I did it. In particular validation 35, you will get the highest accuracy and you pick that value. That means in k value 35, we will get the value data. If the means high accuracy, we resolve. And we just make it the data is the high accuracy, then we can submit. So our conclusion is that in a particular method, if we use in our method, in case of accuracy level has a clearly evident that the proposed algorithm is deeply proficient in a recognize the cancer affected part in CT images. The classification performance in this investigation demonstrate the advantage of the strategy in a speedy, the simple operator, non-incumbent or cheap. And future work we also given that we will be use the high doses of CT images and optimal feature selection with a multi-classifier constituted of the cancer in detection process that we can use. Now you can any questions? I open to all. Any question you can ask? Uh, Let me. I can zoom. Any question you can ask me. So I hope the 10 minutes left. You can ask in last 10 minutes any questions. Or you might be feel for hungry for lunch. We can. Any doubt? I already shared with my data and my you can contact point. You can call me anytime. This is my email ID. You can drop. And this paper also I circulate to the organizer. They'll be given to you. You can read that paper. Also, you need that paper. You can send to a request. I'll send the paper. Any doubt you can ask me. Am I audible? Hello. This is the hello. Am I audible?
Yes, sir.
I've already said my PPT. The paper you can share to the participant, and this is the contact email ID. You can contact anytime, no problem. Any doubt you can ask me. No problem.
Sir, I simply want to know when we go for deep learning, so many trained models are there, and then in certain cases, we are not using that direct trained models which are trained on images. We go for the transfer learning. Which technique should be the best, and how we decide whether it is according to the data, or it is means it is according to the image size and or something else. Because can we go for transfer learning direct, use the ready-made model and make our architecture add on with that, like
Yeah, I
that?
got your point. You have very good questions. So first of all, you remember uh, all the methods are good in respect to their strength and weakness, right? First of all, what will do? You think what is the properties of your data? Find the statistical inference of the data. If your data points are very highly correlated data, then you go for the any and in auto encoder techniques. If your data points are very noisy, and that point we can go for the and for the you can for the I can call the under incomplete auto encoder data. And transfer learning, what I'm saying, if your data points, you will always tell the huge data points are there, but I do we have to find out which data point is more valuable for the taking the decision making process. For that you can go for the transfer learning, or you can go for the your convolutional neural network. So any type you can do it. But thing is that the same data points you can apply 2 to 3 methods. You can compare which method give the more accuracy, and as per the satisfaction level, that method you can do. But as per you are saying the transfer learning, you also people are now towards crazy towards the transfer learning, but sometimes transfer learnings are not giving very good result as per the some data points, like your water images data points or underwater image data points. That times the transfer learnings are may not giving a very good result.
Sir, one other question is here. When we are taking some hyperspectral images for the analysis,
Okay.
sir, my question is, we have got two aspects. One are the layers and other is the image size.
Okay.
So, I was just scrolling through the data. Some of the data have means less layer, more layer and small image size, and vice versa.
Yeah.
So, what kind of deep learning approach should we adapt?
Okay.
Can we take
So
these parameters like
okay.
or not?
So what will do here? You in this case, what will do? You go for the you're saying the high layer and the less image you are saying, right?
Yes, sir. For example, one of the data set I am using,
Okay,
it is
okay,
having 60 layers.
okay.
Yeah.
So you find the in the system layers, you go for the individual layer and applying the pooling method. Okay,
Okay,
and
sir.
you extract if each pooling methods, what will do? You find the information gain of individual layer, and that you put in your own matrix, and that own matrix you supply as a convolutional neural network. That will be the good result. But
Okay,
the
sir.
thing is that
Yeah.
you don't skip any layer, because if you skip any layer, there may be chances the premature conversations, because you don't know which one give. Even also the his silent feature of that particular neural network may be having the leading role for the decision making. That is the only the beauty of your convolutional neural network.
Fine,
All
sir.
all the input factor must be participated in a neural network concept.
Sir, if I go in this way, sir, I really want to ask another question, sir.
Uh-huh.
Uh, when we are taking the size, means आप वो batch बनाते हैं.
Yeah,
So
yeah.
when we are taking the batch size as 25, and when
Okay.
we are taking the batch size as 5. So with 5 or 7, we are taking the minimum batch size because our layers are more.
Yeah.
And then we are taking the lesser batch size because
Yeah.
otherwise the system is not going to process it. So when we are going like this, we are going to get 100% accuracy.
Okay.
Is it just because we are taking small batch size, or it is just the training of the network is there? That's why we are getting.
No. What will do? You take the mean average of the batch size. Okay. You particular don't consider the 5 and 7 and like that. You find the mean and take the average of the total batch size. You take that one. That will work.
Okay, sir. Fine. Sir. Thank you, sir.
Okay. Any doubt from your side? I'll take some water.
I think the participants, they have the questions. Moreover, you have given contact, the address and other details. So I thank you, sir, that you have spared your time for our session, and I hope that the participants will be benefited. Thank you. Next session will be started.
Am I audible? Should I leave?
Yes, sir.
Okay, thank you.